So let me go into it. What we are actually discussing is the type of algorithms, right? So we see that there are non-recursive algorithms and recursive algorithms, and we are going to see the analysis on these algorithms, right? Now let me go because we have two full periods and we can go slowly also. The thing is, I want you people to be interactive, right? Now, can anyone say what is this summation I is equal to 1 to n of 1 is equal to n? What is this actually saying out?
Sum of n numbers.
Yes, sum of n number of one constant item, right? If I put any other number like 2, 3, or I can consider them as a constant c, and I can calculate it as n into c, n times c. So one summation I is equal to 1 to n is nothing but n times c, right? So that's what I'm actually doing here, right? Now, what is this? Summation I is equal to 1 to n I. Here I is not a constant, I is actually a variable item. So what I have to do, I have to substitute the value of I. So 1 plus 2 plus 3 plus dot 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 plus n. So each value will be substituted, and in previous class you said it is going to be an arithmetic progression, and I'm going to get the result as n into n plus 1 divided by 2, right? So far so good. That's what the revision. Yes, shall we proceed here?
Yes, sir.
Yes. Now I'm going to write this formula in a somewhat different way, right? That's what the actual formula we will be using for all our problems. And I'm going to write this entirely in a new way. Summation I is equal to 1 to n of c. You said that it is going to be n into c. Why? Because it is n time multiplying the c, or n time adding c. So you said it as nc. Now why you said here n is nothing but here there are n numbers between 1 to n. Am I right? There are n numbers between 1 to n. If it is I is equal to 0 to n, what will be the answer here?
C into n minus
Same,
1.
sir.
0 into n minus 1. How n minus 1?
Same, sir. And C.
No, so let me count like this. You are having a number 2 and you need to add it 0 to 5 times. So how many times you have to add? There is a constant number 2 and you need to add it 0 to 5 times. 0th time take 2, first time take 2, second, third, fourth, fifth. How many times you will be adding this 2? How many times you will be adding this number? If you are going to add 0 to 5 times, or I is equal to 0 to 5. Am I making it clear, or am I confusing? Yes, n plus 1. That's what I'm asking. I'll come one more time. So assume that here I'm having I is equal to 0 to 5. I is equal to 0 to 5. See, if it is like that, I should put n plus 1. And assume that if I'm not having n, I'm having something like n minus 2. What you will be doing here? So always this is going to be a problem between the lower limit as well as the upper limit in the summation term. So I need a constant formula so that I can multiply c with some other constant term so that I'll be very clear, right? So what I'll do is I'll use a constant formula here. If it is I is equal to 1 to n, what I will do is I will do a formula here. So my formula is I will consider this as upper limit. This is upper limit u, and this as lower limit l. Am I right? So for summation, I'm having this as a lower limit and this as an upper limit. So what I will do is my formula will be u minus l plus 1. U minus l plus 1 into the constant what you are having. U minus l plus 1 into the constant what you are having. So what is u minus l plus 1 is nothing but how many numbers are going to be there in the summation interval is going to be calculated by u minus l plus 1. Now if we calculate n minus l is 1, n minus 1 plus 1 will be giving me n into c. Am I going good? So you are actually getting this answer NC, but using this formula, that is upper minus lower plus 1, right? Is it good? Please be interactive.
Yes, sir.
Yes. So please say the answer quickly so that will be fine. Okay. I want everyone to say the answer. So this is the most important of all the formulas. We'll be using it large number of times in our analysis. This formula will be used large number of times. In many scenarios, this formula will be used, and we need to understand when to actually use this. Now the main thing to understand here is, here instead of having C, if you have a variable term like I, you should never use this u minus n plus 1 formula. Right? Never use this formula if a variable term is there. This is also same. Summation I is equal to 1 to n I. This is also summation I is equal to 1 to n, but inside I'm having a constant. So what is the difference here? Here in I, I'm having the limit variable as I itself. The same I is coming here. So for each iteration, the I value will change. But here, both I and n is not present here. So the limit variable will not change here. Directly assume some constant number is there. So this is a formula, this is a separate formula. Right? So far, so good. Shall I go to the final formula? So the thing to you have to keep in mind is this one formula and this formula. So for these two formulas, if you keep in mind, more than enough. Shall I proceed?
Yes, sir.
Yes. Now, a small IQ question from this.
Sir.
I derived a formula from this, right? Now, a small thing to derive from here. Here, I'm saying summation I is equal to 1 to n. I is equal to, you are saying n into n plus 1. The same thing, I'm doing a small change here. Instead of I, if I put I is equal to 0, I is equal to 0 to n I. What will be the formula?
Same formula, sir.
Same formula. Why? Because if I add 0, nothing is going to be changed. Here it will come like 0 plus 1 plus. Am I right? It will come like 0. So if I add 0, nothing is going to change. Right? So it is going to be the same thing. Right? So, but I can do a small change here. The change is, right, I'll write another formula here. Exactly same as this particular formula I'm going to write here. What is that is summation. And if you understand this third formula, this third serial number formula better, you can directly say me the result before I can write. I write summation I is equal to 1 to n minus 1. N minus 1 I. Can anyone quickly say what will be the formula for this? Don't think too intuitively like arithmetic progression or some other thing. Just think of this formula. If it is I is equal to 1 to n, it is giving like n into n plus 1. N. If it is n here, you are saying n into n plus 1.
N minus 1 by
If
10
it is
into n minus 1 by 2, sir.
come again.
n into n
n
minus
into n minus 1 by 2.
Very good. Can you say how it is?
In place of n, we place
Yes, instead of n, I can put it as n minus 1. So it is n minus 1 into, what will come here? Instead of this n, I should substitute another n minus 1. So n minus 1 plus 1 divided by 2. So what will come? I can cancel the n minus 1 plus 1. That is minus 1 and plus 1 will become 0. So it will give me the result. As he said, the answer will be n minus 1 into n by 2. Yes. That's what these kind of small things only will be there for derivations. Initial derivations will be very simple. If you understand these small things, then the big derivations will become very easy. Right? Now coming to this. Quickly say summation I is equal to 1 to n minus 2.
n minus 2 into n minus 1 by 2.
N minus 2
Very
into
good.
n minus 1
Very
by
good.
2.
Very good. That's great. Ultimately great. Very good. It is nothing but n minus 2 into n minus 1. If it is n minus 3 means n minus 3 into n minus 2. If it is n minus 5 means n minus 5 into n minus 4. So everything is actually like that only, right? N minus 2 plus 1. So I'm going exactly like the same formula. I'm just substituting everything here and then getting the result. So that it will be very clear when you turn it back and see. Now we are very well ready to directly take on the analysis of finding maximum element in a given array. So I'll put here n minus 2 into n minus 1. If it is n minus 4, what we will do?
N minus 4 into N minus
N minus 4 into N minus.
That's it. That's it. Very good. Very good. You are very fast and I think more intelligent. So this is the thing. We can take the screenshots. So the most important are these the formulas that are ticked in red. I am ticking the formulas right. So these ticked formulas are most important. These alone, if you understand, then it is enough, right? So these formula summation I is equal to 1 to I, summation I is equal to 1 to n into constant, summation I is equal to 1 to n or n minus 1 of I. So this is ready. We can easily go into these kind of algorithm problem solving, right? Shall I go to the next screen?
Yes, sir.
Yes, sir.
Yes. Thank you. So I'm going into the first non-recursive algorithm problem solving, that is finding max element in a given array. Finding max element in a given array. So what is that finding maximum element in a given array? Assume that I'm having some element like 3, 6, 5, 4, 9 and 2, right? So what is the maximum element in this given array? 9. So you're saying that 9 is actually the maximum element. So how can you say any logic for finding this? It is a very simple program. Can you say the logic how to find this?
Comparing two, sir. First one and second one, sir.
Okay.
Increment the
After
index.
comparing, if it is larger, and keep into another array, sir.
Yes, that's great. Right. So
After
any other logic?
same,
Sir, sort the first sorting
Okay.
after finding like.
Okay, another person saying that I have to sort and take the first element if it is in descending order, right? So both things are exactly correct. But if you sort everything, then what will happen is for sorting, we know the complexity of sorting is n squared. So n squared time it will take. But I need to solve this problem in n time or less than that time. I have to solve this problem, right? So we will see how to do that. The person who said first is more or less correct. So what I will do is I will consider the 0th element as the largest element. Let me consider this like an array starting from index 0, 0, 1, 2, 3, 4 and 5. So I'm just putting the index, array index starts from 0, right? So I'm just starting from 0 and then analyzing everything. So what I have to do is I need to put everything in an array and then I have to place what is the maximum element, right? So here what I will consider is I will consider the 0th element as max element. I will consider 0th element as max element. Right. So once 0th element is considered as max element, what I will do, I'll fix max is equal to 3. Then I'll go to the first element. If any element is greater than the max element, I will swap that element and the max element. So I compare max is equal to 3 now. 3 will be compared with 6. I found that one element 6 is actually greater than the max, so I'll change the max to 6. Similarly, 6 will be compared with 5. I found that my max element is the largest. So I will retain the max element as the largest element. Right? Similarly, I go for 4. And when I come to 9, right? When I come to 9, I found that 9 is actually bigger. So I will swap again. So this is how I'm going to do. Right? Well, let me write the algorithm directly. So the procedure for writing the algorithm is same. Algorithm max element. I'll write algorithm max element. What will be the input? The input will be an array of size n. So I'll put an array, right? Array. Okay, I'll put an array. So let me write what are the inputs. The input is nothing but an array A starting from 0 to n. 0 dot dot n means there are n element and 0 dot dot n minus 1 means that there are n elements starting from index 0, right? So far so good?
Yes, sir.
Yes. What will be the output? Max element. Output is nothing but max element, right? Now I'll go here. I'll go for my logic. So what I will make first is I'll make something like max element is equal to a of 0. So I make max element as a of 0 initially. Then what I will do is for I is equal to 1 to n minus 1. It is nothing but for I is equal to 1, I less than or equal to n minus 1, I plus plus. When I write like C program or C++ program. But when you write like an algorithm, you need not write like that. You can just say like for I is equal to 1 to n minus 1, like that. For I is equal to 1 to n minus 1. If max element is greater than a of I. If max element is greater than a of I, what I will do? I will need to swap, or I can just make max element is equal to a of I. That element will become max element. Sorry, if max element is less than, I'm sorry, right? If it is max element is less, then I have to make the new element as max element a of I, because a of I is greater than the max element. So the current max element will be replaced by the new max element, that is a of I. Once this for loop is again and again repeated, finally the end of the for loop will give me the final max element that I will return max element, right? So now I'll explain one more time what is being done. So, assume that I'm having an array, so it is from a of 0 to 5. A of 0 to 5 is there. Initially max element will be a of 0, that is 3. Initially max element will be 3, and I'm starting from 1. I'm not starting from 0. Why? Because 0 is already being assigned to max element. So I need not start from 0. I can start from 1. So now if max element, what is the current max element value? Can anyone say? What is the current max element value?
3, sir.
3. So if 3 less than what is a of 1? Initially a will be 1, I will be 1. So what is a of 1? 6. So 3 less than 6. So what I have to do? Max element is equal to 6. Now max element is updated. Again go to the for loop. I will become 2 now. Now max element is 6. 6 less than what is a of 2? 5. 6 less than 5, not false. So I'll come out. So I become 3. 6 less than 4. Again not false. Then I'll go to the next one. 6 less than 9. 6 less than 9 is true. So max element will become 9 now. Again I'll go to the for loop. Next 9 less than 2. It is actually false. So I'll come out and I will return the max element as 9. Right? Is it understandable, the algorithm? Is it so? Is it good?
Yes, sir.
Yes. Now the algorithm is fine. Now we are not here to write only the algorithm. We are here to do our first time complexity analysis, right? So before going for time complexity analysis, as I said, use some basic formulas to understand. I will also let you know some other things what you have to understand when you estimate the time or space complexity of a given program. Point number 1. If you are doing any small arithmetic operation, so you'll be asking me, sir, what is small? Small is nothing but addition, subtraction, multiplication, division, modulus, all kind of binary arithmetic, unary arithmetic, ternary, all arithmetic operations I consider as small. What is large then? Large is nothing but if you do complex arithmetics like one addition, one subtraction, like a wrong quadratic equation solving, then it is large. If it is single binary, unary or ternary, it is small. Okay. So now what I'm going to do is I'm going to consider max element equal to a of 0. Now it is just an assignment of the value of max element equal to a of 0. Now can anyone say what will be the time that will be used to transfer the value a of 0 to the another variable max element? How much time it will take?
1.
1 unit of time. Very good. 1 unit of time. Shall I represent it as big O of 1? Shall I represent it as big O of 1?
Yes, sir.
Worst case, it will take 1 unit of time. So I say it is big O of 1. It will not take more than 1. That's what I'm saying. The upper limit, the tightest upper bound is 1 unit. It will not take more than 1 unit time. Now coming into this for loop is having some condition. So what is this condition is nothing but how many times this for loop will take place?
N minus 1 times.
Think well and say. So I can write this for loop as, this for loop can be written as summation I is equal to 1 to n minus 1 1. Why I am writing 1 is nothing but here I am having a condition if max element less than a of I. The condition checking will not take more time, and the major time is transferring a value from a of I to max element. So that's what the time actually will take. So for I is summation I is equal to 1 to n, this will take a time of big O of 1. Right? Big O of 1 time it will actually take. Now, for I is equal to 1 to n minus 1 can be written as summation I is equal to 1 to n minus 1, 1. So, how many times this for loop will execute? U minus L plus 1. Use the U minus L plus 1 formula. U minus L plus 1 formula. What will happen? N minus 1 minus 1 plus 1. So what will happen? N minus 1 times it will get executed. Am I right? Am I right or wrong?
Yes, sir.
So n minus 1 times it will get executed. So what we actually need to do is, we need to identify what is the major time a program will actually take. Right? Some people will say that for getting inputs, I will be making some time. So how you be calculating that? For producing output, what will be the time? Right? So when you estimate the time or space complexity of an algorithm, you should not consider the time for getting the inputs and time for printing the outputs. For that, you should not estimate the time. Why? Because that involves user also. Because when giving the inputs, the user may become late. It is not the system being late; it is the user being late. So you should not consider the time complexity of inputs and outputs. Only the processing time of the program alone should be considered. Right? Now we will go into the detailed analysis of the program. So the detailed analysis, the main component of the program is nothing but what is the basic operation of the program. Basic operation is nothing but comparison. Find the basic operation of the program and identify how many times the basic operation actually take place. Right? So what will be the time complexity of this? We need to estimate. Right? So now I'll delete this particular question. Right? Right, I'll write something here. Analyzing the non-recursive algorithms. Analyzing the non-recursive algorithms. What I have to do, right? In that, when I need to analyze the non-recursive algorithms, it is very easy to analyze non-recursive algorithms compared to recursive algorithms, right? So how I should do? There are only 4 steps to be done when I go for analyzing non-recursive algorithms. What is the first step is decide on parameters indicating the input size. Decide on the parameters indicating input size is nothing but what is the size of the inputs. I know that it is n, right? That is most important because I am operating everything with respect to n only. So where I got from that n, I got from the input size, right? Second, the most important, which will come in recursive also, what is identify the basic operation of the algorithm. Can anyone say now? Just I said, right? What is the basic operation of this algorithm?
Comparison.
Comparison, right? Identify the basic operation of the algorithm is comparison. Next, if we identified what is the basic operation, we need to check take how many times the basic operation take place. A basic operation is executed. How many times the basic operation is executed, right? Next, sum up the number of times and return as time complex. So we need to sum up everything and return it as time complexity of the given algorithm, right? Using how to sum up is we can use standard formula. Using standard formulas, we saw some formulas, right? Using those formulas, we can actually do it on. Right now, we will use these steps to find the time complexity of this small algorithm. So we have the parameter. What is the parameter? Is nothing but n. We know what is the parameter, and we know how to solve this. What is the basic operation here? As one of you stated, it is going to be the comparison. So how many times that comparison is going to take place? That's what I need to identify. So I'll just do for I is equal to 1 to n minus 1. How I got this limit? I got this limit by using the for loop statements. My for loop starts from I is equal to 1 to n minus 1. So using this for loops, I got this, and I'm putting inside as 1. Why? Because this max element comparison and then assigning will totally take 1 unit of time, right? So what will be the answer for this? I'll consider this as u and this as l. So my formula will be u minus l plus 1 into 1. So what will be the answer? I'll put here what is u value? N minus 1 minus L value is 1 plus 1 into 1. We'll be getting the answer as N minus 1, right? So now I got the result. I need to write this in terms of asymptotic notations. I'm actually more interested only in the worst case complexity instead of the best or average case. I need to find only the worst case. So how to write the worst cases? Very simple. When you represent the time complexity of a given algorithm or the space complexity of the given algorithm, you should omit all the constants. Here, what is the constant? 1 is the constant, and you should omit 1. And if you have higher polynomials, like if I have n squared plus n minus 1, so what is the highest polynomial here? N squared. If you are finding the worst case complexity, you should take the highest polynomial in the given term. In this, what is the highest polynomial? N. So when you find the worst case complexity, just consider the highest polynomial in the given term and omit all the constants. So my complexity will be big O of n. You should not write like big O of n minus 1 or big O of n minus 2 like that, because constant should not be considered. Okay, so I should write like big O of n only, right? So the algorithm in the worst case takes big O of n time. That's what the worst case complexity of my algorithm, right? The thing to understand here is what is the best case of an algorithm, right? So can anyone explain me when the best case will come, or what will be the best case of this given algorithm?
When highest maximum number is present at first index, sir.
Very good, very good. That's great. Very good, fine. Very good, very good. What is your name?
Deepak, sir.
Deepak. Very good, Deepak. 5, 6, 4, 3, 2, 9. Right? This is actually one kind of array. Assume this is going to be one, and this is going to be the other. Let me write another one. 8, 3, 4, 2, 1, 6. So this is another thing. And next I can have something in the middle. I can consider that as average case. Right? Now how many elements are there here? What is the n value here? 1, 2, 3, 4, 5, 6. So it is 6. According to the derivation, it says that the complexity of an array of size 6 for finding the max element will be big O of 6. For this array, what is the complexity? When I give the full input, what will be the complexity of finding 9?
Because
Big
6.
O of n.
Big O of 6. Why you are saying big O of 6? Because I have to do 6 comparisons to find the 9. I have to do 6 comparisons to find 9. If it is for this algorithm, for this particular input 8, 3, 4, 2, 1, 6, what will be the complexity?
Big O of 1.
Big O of 1. I have to say it is as big O of 1, or I can also say it as big omega of 1. Why I am saying big omega of 1 is nothing but I am actually very sure that below this my best case cannot go. I at least require 1 unit of time to find the max element, provided that my max element is present in the 0th location of the array itself. Like here Deepak said, whether in the first location itself I am having the max element, so I need not search here. So this max element less than a of I, this is the basic operation, right? This for if it is located in the first element max first location itself, for all the other location this condition will become false. If this condition become false, then this will not execute itself. If this didn't execute, then this time is not needed, only 1 unit of time is needed, and that will be the best case. Right now you clearly understand what is the how to find the worst case or best case for this very simple algorithm.
Yes, sir.
Yes, right. So this is actually in the worst case, I'll get big O of 6 to find the maximum element 9, and for this, I'll be getting something like big O of 1 for finding the maximum element 1. Sorry, 8. So this is the maximum element here, and this is the maximum element here, right? So far so good.
Yes, sir.
Yes.
Sir.
So shall I move on to the next algorithm?
Sir.
Yes. Okay. Okay, please take screenshot. I'll delete this. Shall I delete this?
Yes, sir.
Yes. Next one is checking whether the array is unique or not. Checking whether the array is unique or not unique. That's what we are going to check. Right? Let me write an array like this. 1, 2, 3, 3, 5. 1, 2, 3, 3, 5. Right? So how many elements are there in this array? As per deciding on the parameters of the input. What is the input size?
5, sir.
5. The input size is 5. So in this input, now I have to find whether the array is being unique or not unique. Unique is nothing but all the elements in the array should be different. There should not be any element that is having exactly the same value, right? So I found that here 3 and 3 are actually being same, and I should say that the array is not unique. But I'm directly seeing it manually and then I'm saying it. But when a computer does it, how it should do? That's what the actual question is. What I can actually do is like in the previous example you said, right? Element by element comparison. That's what I have to do. So what I will do, I'll compare 1 with 2. Okay, first element is not equivalent to the second element. Next, what I will do, 1 will be compared with 3. Okay, first and 3 is not, the third element are not the same. Next, first and fourth element, and first and fifth element. First, this comparison I'll first finish and say that my first element is unique, right? Next, what I will do, I'll compare second with third. Next, this will be compared with this. Next, this will be compared with 5, right? Next, I find that both first and the second element are unique. Next, what I will do, I'll compare 3 with 3. Now I found that 3 and 3 are same, so they are not unique. In this way, I have to make the comparisons, right? So now a small question to you, what I have to ask is, Now I'm actually checking 3 with 3. Next, if it is somewhat like 4, what I should do? I should go for 3 with 5. Whether I have to compare 3 with 2 again.
No, sir.
Why?
Already compared, no, sir. 2 and 3.
Yes, it was
Already
already compared by 2. So comparing 2 with 3 is same as comparing 3 with 2. If you do the same operation again, then what will actually happen is I'll unwantedly wasting my time complexity. It is actually increasing my time complexity of an algorithm, right? So in this way, I have to proceed and find the result, right? So now we have to understand when doing this logic itself, you need to understand what are the ingredients of your program itself. Right now, when I do a single comparison, I know that this element should be compared with this should be compared with this should be compared with this should be compared with this. For comparing one element with all the other elements in the given array, I require one for loop. For comparing one element with all the other elements in the given for loop, I require one for loop, right? And I need to repeat the same process for all the other elements in the given array also. So comparing this one element with all the other elements, that particular logic should be repeated for all the other elements also. So how many for loops I totally require? I require 2 for loops. So in this way, when understanding the logic of the program itself, you should be very clear that how many for loops is required and how many variables are required for the given program. If any one for loop you go extra, or any one array or any one variable you take extra, then your program is not efficient, right? So in this way only, if you solve any complex problems in code challenges or anything, you will be getting some errors. You will be getting the output, but you will not pass the test cases. Why? Because you are actually solving it in time, right? Yes, so what we will do, we will be doing the analysis algorithm for this and we'll be analyzing this. And before going for the analysis, let me finish up the max class link. Okay.